So I'd like to discuss then in this video, maybe the next one, why is it so hot on Venus? And what we'll do then is to talk about this is we'll sort of draw the Earth here as comparison. We'll draw Venus here. And as we mentioned in the last video, the atmosphere on Earth is made of a very manageable amount of nitrogen and oxygen. I say manageable because, well, we're certainly able to live here. So it's N2 and O2. But if you go to Venus, it doesn't work like that there on Venus. Of course, it's a very thick deck, cloud deck, of, as we mentioned, the sulfuric acid, which would corrode you, but I'll leave that out, and poison you at the moment. But I'll just sort of think about Venus here as the carbon dioxide in the atmosphere. Okay, so a couple things then, is that what you're going to start thinking about now as well? When the sunlight comes down from the sun and encounters our atmosphere on the Earth, it has a very well-defined action, which we know what happens, and I'll just sort of summarize it here. Remember that our air, that I'll sort of reserve air for the word on Earth here, remember it acts as a blue filter due to the scattering, so air tends to remove blue from the sunlight. So the question that happens now is, well, what happens when sunlight comes down on an atmosphere that's all carbon dioxide? Well, let me show you something over here in a simulation. It'll look like this. So what we have here is a flashlight that I can turn on by dragging the slider over here. And the molecule that you see in the center of the screen here can be any one of these I can select over here. So I can make it carbon monoxide or nitrogen or oxygen or carbon dioxide, water, that kind of thing. And what I can do then is then I can sort of turn on the light and make it visible or infrared. And let's see what happens here. So the first thing that I'll do is I'll just sort of turn on the visible light here. So the photons that will come out of the flashlight will be visible. And I'll just turn them on and see what happens to carbon monoxide. So those yellow photons going across are hitting the carbon monoxide and not much is happening. So what that means is that carbon monoxide would just be transparent to light. Just carbon monoxide isn't affected by it. How about nitrogen in our atmosphere? Goes right through. Now, this simulation isn't exactly accurate to what we discussed in our class because we'd like the blue light, invisible light, to be scattered around by the nitrogen. That's our blue sky inner workings, but these photons appear to be yellow, so they're just sort of passing right through. Remember, if they were blue, maybe they'd be going off in all directions. Oxygen, about the same thing, no reaction. And carbon dioxide, which is what Venus's atmosphere is full of, no reaction also. So conclusion here is that from the quick simulation I showed you here, is that visible light seems to have no, let's say, no effect on CO2, which is in Venus's atmosphere, or the N2O2, which is in our atmosphere. Okay? But of course, light can be much more than that. So back we go, something like this. Okay, let's turn the flashlight back off again. Let's go back to carbon monoxide and let's choose the infrared. Okay, so what's infrared? Well, it's basically red light think of red light that you can see, but it's a little further out, a little bit lower energy than that. So it's near the red part that we can see, but it becomes invisible at that point that we can't see. Okay. And so what I'll do is I'll just sort of turn it on here. Turn on the flashlight. So here's carbon monoxide being hit by infrared light. So you can see something different is happening here. First thing you see is the carbon monoxide is sort of wiggling back and forth. That tells you that the infrared photons are affecting the carbon monoxide molecule. And the other thing you see is scattering is going on. If you recall the word scattering back from our blue light analysis, you see that when the photons go in, when they scatter, they sort of go off in opposite directions, like that one right there, like that one right there, and that one right there going down, that one right there, that one right there. You get the idea. The photons go in, sometimes they cause the carbon monoxide to wiggle, and when they wiggle, the carbon monoxide spits a photon out in some other direction, and that's called scattering. Okay, how about nitrogen? Nothing. Once again, nitrogen has no sort of reaction or effect to infrared light. How about oxygen? Nope, still nothing there. How about carbon dioxide? Check it out. So same effect as the carbon monoxide, but don't worry about the carbon monoxide. That's not something that we think of as being on Venus. I'm sure there's some there, but it's not part of our conversation. But carbon dioxide is. So it appears then that the carbon dioxide in Venus's atmosphere has a very strong reaction, as you can tell, to infrared light. The molecule wiggles, it scatters photons in all directions, and that's very important for what I'm going to tell you next. So let's go back to our writing screen, view concluding comments, and I'll show you more ramifications of this. But remember this. This is the takeaway here. Carbon dioxide is affected by infrared light. So we go back to the iPad over here. What we can see here is I'll just sort of call this IR. Infrared, this is the proper spelling. It isn't infrared or infrared or anything. Infrared is how it's spelled. Let's say strong effect on CO2. We won't worry about the nitrogen and oxygen because it's Venus that has the carbon dioxide in the atmosphere. So what happens then is the sunlight that comes down from the sun, of course, it has the infrared light in it. Has the infrared light in it. So what that means is when sunlight comes down and encounters some of the CO2 in Venus, it doesn't all just go down like that. It starts to scatter in all directions. Just like I sort of showed you much earlier with the blue light and the blue sky. Well, this is what IR does in response to the carbon dioxide on Venus. And so I'm going to throw a term out at you here and show you something in the next video, but the term I'm going to throw out is the word global warming, because I know you've heard of carbon dioxide in the news in the context of global warming, and I'll show you how that works in the next video.